Okay, so knowing that this is a part of the semantic memory. Semantic memory is a knowledge for general knowledge. And we can talk about the structure and function of semantic memory in this video. This is a picture. We covered all the pieces of the puzzle. Now we are in this last piece, the memory. And we're talking about long-term memory here. Long-term memory is further divided into declarative and non-declarative memory, but we are specifically talking about the declarative memory. That is conscious and that you can talk about, as opposed to the non-declarative memory or procedural or implicit memory, which is difficult to talk about or used without bringing it to consciousness. In this video, we're gonna be focusing on episodic and semantic memories, and more specifically semantic memory. We classified using the usually used taxonomy the long-term memory into declarative memory, also called explicit memory, and non-declarative or implicit memory. This is the memory that for procedures like your habits, skills fall under this category. Declarative memory because you can talk about it, and explicit because it comes to your awareness when you access that information. Depending on the content of this declarative memory, we have two kinds of declarative memory: episodic and semantic. Episodic memory is memory for personal experiences, and semantic memory is memory for general knowledge. And for this video, we'll specifically talk about semantic memory. Well, an important question is, why only semantic memory? To start with, what applies to semantic memory for the most part, at least in terms of the structure and processing of information, equally applies to some episodic memory. But there's another reason why we specifically want to talk about semantic memory. Remember, we are trying to solve the puzzle, which is how we comprehend a written text, which inevitably involves language. And semantic memory and language are interconnected in the sense that for you to use in language, you need to use the knowledge base, and the knowledge base that we use is the semantic memory. So that's one reason why we are concentrating more on semantic memory as opposed to the episodic memory. Now, when we talk about semantic memory, we'll talk about two different aspects of it. We'll talk about the structure of semantic memory and the processing of semantic memory, specifically in the context of one of the models. Again, we'll talk about the structure of the semantic memory and the processing of semantic memory, of information in semantic memory. Well, there are two types of semantic memory. Semantic memory one, which is your memory specific to conceptual knowledge about concepts, apples, books, humans, whatever it is that you have concept of, which is an important part of your semantic memory, is semantic memory one. Semantic memory two is situational knowledge. It's a knowledge you have, a general knowledge you have of different situations, like how to behave when you go to dine-in restaurant, which is different from how you behave when you go to a drive-through restaurant. So this knowledge, this is again a general knowledge about situations, so it's called situational knowledge. The conceptual knowledge is a general knowledge about concepts. It involves not situations, but different concepts. The structure and the way we process information is same for both conceptual knowledge and situational knowledge, semantic memory 1 and semantic memory 2. But we will discuss the structure and processing information in the context of conceptual knowledge. So you're doing two things at the same time. You're knowing what conceptual knowledge is. You're also knowing the specifics of the structure and processing of information specific to conceptual knowledge. But keep in mind that it equally applies to situational knowledge. There are two types of semantic memory. Semantic memory 1, which is conceptual knowledge, and semantic memory 2. What is it called? Can you retrieve? Yes, that's the situational knowledge. So we'll talk about these two things. We'll talk about the structure and processing aspect of the semantic memory, which applies to both SM1 and SM2, but we'll discuss this in the context of SM1. Now, I want you to keep in mind, structurally, we'll be using terms like concepts, and there's another term. Again, we'll come back to this to fill this information in together. And we'll talk about processing information in semantic memory. We'll talk about concept activation and two other things. Again, we'll fill this as we go. Okay, so semantic memory 1 is the conceptual knowledge. This has information about different concepts that you've learned. And if you think about it, your conceptual knowledge is like a mental dictionary. Have you ever tried to access an online dictionary? Well, in an online dictionary or any dictionary as such, when you look for the meaning of a word, it's defined in terms of other words. And if you look for the meaning of that other words, again, it's defined in terms of the words that already exist in the dictionary. It's like a never-ending loop. The idea here is conceptual knowledge is a network of different words, and these different words are concepts. So in that sense, your semantic memory is a mental dictionary of meaning. How do we create these concepts of the mental dictionary? Well, if you remember, we extract meaning from our common experiences. Like you have experienced dog, and you've experienced a different dog. You experienced a third dog. So you assimilate this information or put together what is common across these experiences. Then you have this concept of dogs. So anything that has these features then belongs to this particular concept. So what is the utility of this? The utility of concepts is when you experience or encounter a similar object, then you can easily categorize it as belonging to that concept as opposed to coming up with a new concept. So it simplifies our lives so that each and every time we experience an object similar to what you've experienced before, you're just categorizing it. So remember, it's a part of perception, categorizing an object as one instance of a bigger category of things. Well, if conceptual knowledge is a general network of these concepts that you have developed, by connecting different concepts, you can also create knowledge base specific to general knowledge about, okay, who is the first president of the United States? Well, this is a combination of concepts. The first president, United States, and whoever it is. So you have this network of concepts that forms a basis of your mental dictionary, but also forms the basis of your general knowledge of the world. In that sense, your semantic memory is also a mental encyclopedia. So semantic memory is a network of concepts. So we'll talk about this semantic memory. It equally applies to both, but we're specifically talking in terms of semantic memory one, which is a conceptual knowledge. So we're going to talk about the structure and process of semantic memory. Several models are proposed to explain the structure of semantic memory, but there's one particular model that's most influential, and that's what we'll talk about now. It's called the semantic network model. One of these semantic network models, the first one to be more precise, was proposed by Collins and Quillian, and along with Loftus, of course. This is called the Collins and Quillian and Loftus model of semantic memory. According to this theory, your semantic memory, the conceptual memory, is a network of concepts. So you have Robin, you have bird. So you know that Robin is a bird. So these two concepts are connected. We know that Robin lays blue eggs. So this blue egg and Robin are also connected. We know that bird can fly. So fly, the concept of flying is connected to bird. The concept of feathers is connected to birds. The concept of animals is connected to bird, so on and so forth. So your semantic memory is a network of different concepts. So you can think of semantic memory as an interconnected network of concepts. Now, when you have a network of concepts, there are two terms we use here. One is the node, and the other one is the pathway. Node refers to the points or locations in the semantic space. This is called the semantic space. The concept is also called a node. And what connects these concepts are these lines called pathways. What are these? Well, these are associations between different concepts, which will determine the kind of relationship between two concepts. For instance, you say Robin has red breast. So this particular line or pathway determines the kind of relationship this concept has with this concept. Now, if you look at it, it's called P. Okay, we'll come back to this in the next slide, which is different from this particular pathway here, which is the connection between this concept Robin and this concept bird. You cannot say Robin has birds. Like you can say here, Robin has a red breast. You cannot say that. So the kind of connection here is called an either connection. Again, we'll talk about in a second, the next slide. The idea is the pathway here is different from this pathway. In other words, the pathways, which are the connections between any two concepts, are associations between concepts that are labeled. One is labeled as P, the other one is labeled as easy, and we'll talk about what this means in a second. And these are directional. In other words, that you can say Robin has red breast, but it cannot say red breast has. So the connections, the pathways are directional. Similarly, you can say Robin is a bird, but you cannot say bird is a robin because that's not an accurate statement. So these pathways are labeled directional associations between concepts. Now, when you say it's a network of concepts, as you already know, a proposition is two concepts and a pathway. Two concepts and a pathway will make one proposition. It is a relationship between two concepts. Like for instance, if you say Robin is a bird, That is a proposition that has two concepts, Robin and bird, connected by a pathway, which is a pathway. Okay, what is a proposition? You already know that it's an idea unit. Robin is a bird is a single, simple idea unit. That's what propositions are. These are truth statements in the sense that these are either true or false. You can think of semantic network or semantic memory. We are talking about conceptual memory here, so it applies to other one also. But the semantic memory one then can be defined as, well, structurally, semantic memory is a network of concepts. Well, remember, any two concepts with a concept is a proposition. So you can also think of semantic memory as a network of propositions. So what is a proposition then? Well, as we said, proposition is an idea unit. It's the truth statement. It is a relation between two concepts. Now there are two kinds of propositions based on the type of pathway. Remember, there are two types of pathways. P stands for property pathway. ESA stands for membership pathway. Well, why it's called property pathway is that this particular connection is is showing the property relationship between these two. In other words, it's saying that Robin has a property of redbreast. Whereas here, it's showing a different kind of relationship between concepts. It's saying Robin is a bird. It's not saying Robin has a bird or has a property of the bird. So there are two kinds of pathways. One is called the property pathway, and the other one is membership pathway. Now, depending on the kind of pathway that connects two concepts in a given proposition, there are two kinds of propositions: property proposition and membership proposition. A property proposition has two concepts, Robin, redbreast, connected by a property pathway. So Robin has redbreast, then is a property proposition. The other proposition is the membership proposition. Example here is the bird is an animal. It has two concepts, bird and animal. The pathway here is the is a pathway. So the two kinds of propositions. We said that structurally, semantic memory is a network of concepts or network of propositions. And we have two types of propositions. Well, remember we said we're going to come back to this handout and fill these blanks. Well, this is the time to fill it now. We already know this is situational knowledge, but structurally, we said that semantic memory is made of concepts. Guess what goes here? Come on, think, you can do it. Yes, propositions. So structurally, semantic memory consists of concepts and propositions. Actually, a network of concepts and propositions. Now we're going to move on to the processing aspect of it. You can see the three important things we need to know about the processing aspect, like how do we process information in a semantic memory, which structurally is a network of concepts or propositions. And we know one concept, which is concept activation, but we'll talk about the other two as well. So structurally, we know what semantic memory is. Now, processing-wise, how do you process information? Or another way to look at it is what happens when you read an idea, a sentence, a simple idea. Well, to understand that, first thing you already know, first thing that happens is concept activation. In other words, whatever concept you're reading that gets activated. If I say Robin, that gets activated. The activated concept is shown here in bold letters. So there is one concept in your mind right now that is in non-bold letters, and it will get active once I say or take the name of that particular concept. Are you ready? Okay. Chocolate. Okay, that particular concept was inactive. It became active the moment I use the term. So the first thing that happens when you read a concept, read about a concept or hear about it, either as a concept in itself, like for example, chocolate, or as a part of a sentence, my friend gave me a chocolate, is that it gets activated. So the first thing that happens is concept activation. Well, that was the first point. Remember the handout? What happens next? Well, whenever a concept gets activated, that activation spreads. It's called spread of activation. Just like if you drop a stone in a still water, what happens? There is a ripple, right? And that ripple continues for a while. That's exactly what happens here. Whenever a word or a concept is activated, it leads to spread of activation, which means that other connected concepts get activated as well on its way of spread of activation. And this spread of activation, it spreads for some time, just like the stone in the still water, the ripples are formed and the ripples stay for some time, but it will never go on forever, right? It is active for some time. In the process of this spread of activation, what is happening is the relevant and related and closely linked concepts also get activated, but not the ones that are too far. So first one is concept activation. The second is spread of activation. So if you remember concept activation and spread of activation, we need to know what this third one is. Well, the third one is, for instance, if you're reading a sentence or an idea like Robin has wings, there are two spreads here. One spread that starts from the concept Robin, the other spread that starts from the concept wing. If I say Trump is a 55th, 45th president of the United States, those two concepts get activated. And those two concepts that are activated spread. The next thing that happens is that these two activations, these ripples will intersect. It's called surge intersection. Surge intersection is when spreads of activation from two different concepts meet. That means you have comprehended the sentence. So the process of accessing information in semantic memory has three parts to it. The first one is concept activation. The second part is spread of activation. The third part is search intersection. One prediction of this model, of semantic network, is that there is faster reaction time for concepts that are closer and slower reaction time for concepts that are far away. So, in fact, there is enough evidence to support this model. Again, there are some specific things that this model is not good at predicting, and that's why we have other models. Faster reaction time for closer nodes, because concepts are closer, then the ripples will intersect immediately. So people will be faster to respond to a sentence that has concepts that are closer to one another as opposed to a sentence that has concepts that are far apart. Okay, to sum up then, we talked about semantic memory, and we said there are two types of semantic memory, conceptual and situational. And in terms of structure itself, a semantic memory is a network of concepts or network of, one more time please, propositions. And processing wise, the first thing that happens is concept activation and spread of activation. And the third thing that happens is, one more time, I can't hear you, louder please. Search intersection, that's correct. The concept activation, spread of activation, and search intersection. The only thing that's left now is to talk about semantic memory 2, which we will in the next video. The semantic memory 2 is situational knowledge. And in that context, we'll talk about schemata and scripts. The idea is simple. If we have concepts for objects that we experience, do we have concepts for situations? Well, by now you should know that we do. We have situational concepts, and those are given different names, but the idea of situational concepts is pretty much same. You have concepts and propositions, but the concepts are not about objects, but the concepts are actually about situations. Thank you. Stay tuned.